All right, we are here, official first lesson of distance learning. We've got chapter 5, section 7. We're going to discuss the first day, and we are going to look today at writing and graphing equations in slope-intercept form. Very important here that we dial in and focus on this concept as it is probably the most important section of the chapter. You get your head wrapped around slope-intercept form, and you are going to be just amazing, good to go with the rest of this chapter. So let's talk about what slope-intercept form is. Slope-intercept form is just defined as a linear equation that is written in the format of y equals mx plus b. So we've seen this similarly in chapter 5, section 1, which we called an equation written in y equals format, known as function form. So today we're just going more in depth and saying that the equation has to be written in y equals your x term and then plus your Lone Ranger number. So we'll talk about the order in which I'm going to write those values, and then what our two important variables mean in this equation. Those two variables, m and b. So m, we should know from the earlier sections in chapter 5, m is the slope of a line. Remember, we find the slope by taking any 2 points and then counting just the rise, how many points up and down, divided by the run. The other way we can find the slope, remember, is our slope formula, y2 minus y1 over x2 minus x1. So those are ways we can find the slope of a line if we are not given it. The other variable in slope-intercept form, y equals mx plus b, is the variable b. That is going to be b where I begin, where I start when I look at graphing. So b, this is the y-intercept of the line. Not the x-intercept, but the y-intercept. So that is the point at which the line crosses the y, the vertical up and down axis. So before we start looking at graphs, we are just going to be writing uno, dos, tres, 3 equations in which I'm going to give you the slope, which again is the m value, and the y-intercept, which is the b value, and I want you to write the equation in slope-intercept form. So all I'm going to do is plug in y equals mx plus b, my given value for m and the given value for b. So as I was saying, we're just going to plug in the given m slope value into my equation where I see y equals mx plus b, and then the y-intercept will get plugged in the b location. So the slope of this line is going to be 1/4. So I'm going to say y equals 1/4 x plus b, the y-intercept is 4. There we go. Equation written in slope-intercept form. That's as easy as it is. Plug and chug. Example 2. Here, m, the slope is -9, and b, the y-intercept is -5/4. So if it's helpful, go ahead and write down your y equals mx plus b slope-intercept form equation and plug and chug. M, the slope of the line, is -9, so y equals -9x plus b is -5/4. That's all we've got for slope-intercept form. Kind of a random example, last one here. We have m, the slope is 0, and the y-intercept b is -5. If a line has a slope of 0, remember that's a horizontal line. So here's what that equation will look like. Y equals 0x plus -5. Another way you could write that, 0x plus -5. 0x is the same as nothing. Plus -5 is just like y equals -5. So either way you look at it is just fine. Y equals 0x plus -5, or if you just have y equals -5, either way is good there. All right, we'll be back with taking a look at some graphing. All right, let's take a look here at graphing equations from slope-intercept form. My first two examples here, you are going to see that these equations are in y equals mx plus b format, while on example 3 here, I do not have y by itself. So that is the first thing I'm going to have to do in order to graph these equations, is make sure first they are written in y equals mx plus b slope-intercept form. So the first two I'm good, so I'm ready to start with part B. And B, this is where I'm going to begin when I look at graphing these equations. I start with B. Remember, B is the y-intercept of the equation. So as I look at the first equation here, y equals negative 2/5 x plus 2, B is equal to positive 2. So my y-intercept, the point at which this line crosses the y-axis, again, the y is my vertical up and down axis, is positive 2. So I'm going to go up 1, up 2, and that's where I'm going to begin. I begin at B. Next, okay, after I plot point B, I'm going to use M, the slope, the rise over the run, for 2 more points on the line. So as I take a look here at my starting point of positive 2, the slope, M, is negative 2/5. So I'm going to rise negative 2, so that means I'm going to go down 1, down 2, and then run 5. 1, 2, 3, 4, 5 to the right. I can continue in that pattern, down 1, down 2, and then 1, 2, 3, 4, 5 to the right. Or I can, from this point, go up 1, up 2, and 5 to the left. Because remember, negative 2 over 5 is the same as 2 over negative 5. So I can go up 2 and then 5 to the left. And there is my line. That's all there is to it. To me, that's a whole heck of a lot easier than making a table of 5 values, negative 2, negative 1, 0, 1, and 2, plugging those in for x, and then finding your y values. That's just me. All right, so that's our first line here. Line 2, we again are in y equals mx plus b form, so I'm ready to begin at my y-intercept, in this case, of negative 3. So from the origin, I'm going to go down 1, down 2, down 3, and that's where I will begin. I am now going to use M, the slope of the line, to plot 2 more points. This slope here, M, is 4. I always want to think of slope as a rise over run fraction. So as I think of 4 as a fraction, that's the same as 4 over 1. So I can rise 4, run 1. So I'm going to go up 1, 2, 3, 4, and then go 1 to the right. I can go up 1, up 2, up 3, up 4. So up 1, 2, 3, 4, 1 to the right. And then my line will go through those points. That's all there is to it. Y equals mx plus b, begin on B, and then go rise over run 2 times. 1, 2, 3, 4, 1 to the right. 1, 2, 3, 4, 1 to the right. Connect. All right, last example, when we are not in y equals mx plus b form, I need to get this y by itself. So first thing I'm going to do is subtract 3x from both sides. And I'll have 2y equals negative 3x plus 8. Now the last thing I'm going to do to get y alone is to undo multiplying it by 2. So I'll divide everything on both sides by 2. And then it'll get me the equation y equals negative 3 over 2 cannot be reduced. X, and then plus 8 divided by 2 is 4. So I'm going to begin at the y-intercept of 4. I'm going to go up 1, up 2, up 3, up 4. And then my slope, negative 3 over 2, I'll rise negative 3, so I'll go down 1, down 2, down 3, and then run 2 to the right. Down another 3, down 1, down 2, down 3, 2 to the right. And I can connect those points right there. So there is my line. There's graphing. We're going to take a look at working backwards from a graph to an equation right after this break. All right, we are back with the final 2 examples here of Chapter 5, Section 7. You may see 3 examples down there below these 2 graphs. These are going to be day 2 of Chapter 5, Section 7. So we are going to finish those up on our next class period. So for today, we're going to take a look at these 2 lines and then work backwards. I'm going to give you the line, you give me the equation. The last 3 examples, I gave you the equation and had you graph the line. So again, what I need is an equation in y equals mx plus b form that describes this line. So where did we begin with this line? What's b? The y-intercept is right here. So from the origin, it's up 1, up 2, up 3. Since it's up 3, that has a y-intercept of positive 3. Now I'm going to pick any 2 points on the line and determine the slope. So I can go here and right there. So my slope is down 1 and then 1 to the right. So negative 1 over 1 is negative 1. You could also go from right to left. You could go up 1, 1 to the left. 1 over negative 1 is also negative 1. Or you could go from the x-intercept to the y-intercept. You could go up 1, up 2, up 3, and go 1, 2, 3 to the left. 3 over negative 3 is also negative 1. So any way you look at it, the slope of the line is negative 1. So the equation then is y equals negative 1x plus the y-intercept, which is 3. Another way you might see this equation is y equals negative x plus 3. Either one of those is just fine. All right, here's our final example from graph to equation. Notice this line has a y-intercept b that is below 0, so it will be negative. This b is down 1, down 2. And then the slope of the line, the rise over the run. To get from point to point, I'm going to go up 1, up 2, so my rise is 2. And then I'm going to run 1 to the right. So 2 over 1 is my slope, which is 2. You could also go, down 2. So negative 2. You could go down 1, down 2, and then 1 to the left. Negative 2 over negative 1 is also positive 2. So either way you go, you get a slope of 2. So my final equation then, if I take a look, plugging in 2 for m, I'll have y equals 2x plus b. b we said is negative 2. So 2x plus negative 2, or if you'd like to just have 2x minus 2, that is a-okay as well. All right, we'll turn you loose for day 1 of the assignment, and we'll be back for this later part of the notes there. That'll be 5-7 day 2. Thanks much.